Hello class. Today we will be looking at section 7.1, apply the Pythagorean theorem. Turn to page 430 and look at number 3. Number 3, the direction says, find the length of the hypotenuse of the right triangle. We know a right triangle is a triangle that has a 90-degree angle. So if you look at numbers 3 and 5, I see a 90-degree angle, and that's identified by my box here. That's my right angle indicators. So I know I have a right triangle. So I want to apply the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. A and b represents the leg of the right triangle, and it forms an L, so that's the leg. And the slanted side of the triangle is your hypotenuse. The slanted side of your triangle is the hypotenuse. Another way to identify the hypotenuse is the hypotenuse is always opposite of the right angle. Looking at number 3, my legs are 50 and 120. So I want to plug that into my formula. In my formula, I have 50 squared plus 120 squared equals c squared. 50 times 50 is 2,500. 120 times 120 is 14,400. And it equals c squared. Add these two numbers, and you have 16,900 equals c squared. I don't want c squared, I want c. So to get rid of the squared, I have to square root both sides. So your little symbol here is your square root symbol. You can work this out by hand, or you can type it in on your calculator. So I'm using the Casio calculator. What I'm going to type in, my square root button, which is here, and 16,900. Press equal, and it gives me 130. So my answer for C and or X is 130. Number 5, same rule. If you notice, the triangle is rotated differently than number 3. But remember what I told you all. The hypotenuse is always opposite from the 90-degree angle. So we know my hypotenuse is right across from the 90-degree angle. So I know that this part here is going to be my c squared part. And 42 and 40 represents the legs. 40 times 40 is 1,600. 42 times 42 is 1,764 equals c squared. Add these two numbers together to get 33,364 equals c squared. Square root both sides. C equals 58. So on your calculator, you're going to type in the square root of 3,364 to get 58. Number 7. Number 7 says describe and correct the error and use the Pythagorean theorem. So if you look at the error here, I have a problem on these two steps here, which causes my answer to be incorrect. It says in step 2, the distributive property was used incorrectly. What they did here was they have 7 plus 24, which gave me 31, and that's not correct. What I needed to do was 7 times 7 is 49. 24 times 24 is 576. Add these up to get 625. Square root both sides. And the square root of 625 is 25. So my answer is 25, not 31. Number 9. Number 9 says find the unknown leg length x. So it asked me to find a leg. So I know that my leg is going to be my A or B value. If you look at the illustration, you have an illustration of a basketball goal. And on the back of the goal forms a right triangle. Your leg is X, and your second leg is 9.8. So for here, I have 9.8 squared plus x squared equal my hypotenuse, which is 13.4 squared. 9.8 times 9.8 is 96.04 plus x squared equal 179.56. My goal is to get x by itself. The first step I need to do is I need to subtract 96.4 on both sides. So if you notice, if 96.04 is on the left side and it's addition, when I move it to the right, the sign changes. Subtract these two numbers to get 83.52. And just another demo on the calculator. I want to key in the square root of 83.52 and then equal. If you notice, it gives me the answer in radical form. I want it in decimal form. So I want to hit the SD button. And that gives me my answer in decimal form, which is 9.14 rounded. X is approximately 9.14 inches. Always remember to write your units down. So number 11 and 13 has a lot of information going on here. It says find the area of the isosceles triangle. What is an isosceles triangle? We know an isosceles triangle is a triangle with two congruent sides. If you look at example 11 and 13, notice you have two congruent sides here. So we know that is an isosceles triangle. Another thing you want to remember with that is that if you have two congruent sides, you have two congruent angles. So what would those two angles be? If I have one 90-degree angle, what would my other two angles be? And remember, those angles have to be congruent because the corresponding sides are congruent. So what would that be? Think about that. Going forward, you have to use the Pythagorean theorem to solve for h. And we know h is the height of the triangle. When you measure a height, it's going to be vertical, up and down. If you look at your base is 16 meters. If you look at this entire triangle, it is not a right triangle. But when I bisect the triangle, it forms a right angle. So you have an altitude here, and that forms a right triangle. What I can do here is I know half of 16 is 8. So my measure from here to here is going to be 8 meters, and my measure from here to here is 8 meters for a total of 16 meters. Half of 16 will give me 8. That gives me one of my legs. I'm missing my second leg, but I have my hypotenuse. So I can apply the Pythagorean theorem. 8 squared plus 8 squared equals 17 squared. 64 plus h squared equals 289. Subtract 64 on both sides. 289 minus 64 equals 225. My height is 15. The question says find the area, so I'm not done. The area of a triangle is 1/2 base times height. Base is going to be your bottom piece, and your height is your vertical piece here. I want to plug in my information. So I have 1/2, 16, which is the base, times 15, which is the height I just found. 16 times 15 is 240, and I know half of 240 will give me 120. We are looking for an area. So when you're finding an area, it's going to be measured to meters squared. 13, you're going to do the exact same thing. Your base is half of 12, which is going to give me 6. You're going to apply the Pythagorean theorem again. So I have my hypotenuse, which is 10 squared, equal my leg, which is 6 squared, plus my height, which I don't know, so I said b squared. So notice I did write it a little bit differently on this side to this side, but I want to show you the difference between the two. When you're doing addition and you have that equal sign. You can turn it however, as long as you're applying that formula. It's still the Pythagorean theorem. A squared plus B squared equals C squared. It's still the same formula. 100 equals 36 plus B squared. Subtract 36 on both sides, and that gives me 64, and the square root of 64 is 8. After that, you want to plug in. And remember, that says B, but your B in this case represents the height. So if that confuses you, just replace that with an H. Everywhere you see a B here, just replace it with an H, because that's your height measure. My area is 1/2 base, which is 12, because you're taking the area of the entire triangle, not part of it, times my height, which is 8. 12 times 8 is 96. Half of 96 is 48 centimeters squared, or square centimeters. You can say it either way. Number 15. 15 says find the unknown side length of the right triangle using the Pythagorean theorem or a Pythagorean triple. So you need to study the key concepts on page 429. Very useful in helping you come up with the answers very quickly. The Pythagorean triple, very easy. So just look over those. You have two ways to solve for 15. So my first way is I want to look at the Pythagorean triple. So if you look at that on page 429, you notice that what's given to me is 30 and 50. And if I look at the key concept, the missing number is 40. Or you can work the problem out the way you know, using the Pythagorean theorem. X squared plus my leg, which is 30 squared, equals 50 squared. So x squared plus 900 equals 2,500. X squared equals 2,500 minus 900, which is 1,600. Square root both sides to get 40. Again, we know that the side opposite of the 90-degree angle is the hypotenuse. So it doesn't matter how this triangle is rotated. Always remember the hypotenuse is across from the right angle. Very important. Number 25. You have two triangles in one. If I look at these triangles, they form isosceles triangles. Find the unknown side length of x. Write your answer in simplest radical form. What is a radical form? When you see the word radical, I should see a square root in my answer. So we know radical means square root. Just like decimal form means you should see a decimal. If it's a whole number, your decimal is understood to be at the end of the whole number. Looking at 25, I have my congruent marks here. So if this is 11, this side is 11, and that side is also 11. And I tell you this time and time again, if you do not see the triangle, separate the triangle, redraw it so you can see what's going on. But I'm solving for x, and I have a leg that's 11. My second leg is 11, so I can apply the Pythagorean theorem. 11 squared plus 11 squared equal x squared. 11 squared is 121. Plus 11 squared again is 121, equal x squared. And I'm going to go to the graphing calculator to show you how to type in 11 squared very quickly. So if you look on the graphing calculator and just pay attention to the keystrokes, I'm going to type in, turn the calculator on, and you hit 11, and you have your raised key here. And then you can say square and equal. Another way you can also do it is you can say 11 and you have a x squared feature here. You have an x squared feature there. So you either can say 11 raised to the second, or you say 11 and then you hit the x squared key here. Okay? And once you finish doing that, you hit enter so you can see what your answer is. And if you see here, I have 11 squared, which is 121. So I have 121 plus 121 equal x squared. Add these up to get 242 equal x squared. If you notice here, I complete a factor tree. So you should be very familiar with how to do a factor tree. If not, just take some time to review a factor tree. Also, another thing that's key is the divisibility rule. So if you can just review over your divisibility rules, that'll be a great help when it comes to helping you factor. So when I factor out 242, I know 2 times 121 is 242. And I break down 121, which is 11 times 11. So everything that was a prime number, and we know a prime number is everything divisible by itself and 1. I'm going to write down all my prime numbers underneath the radical. So I have 11 times 11 times 2. If you notice, I see a pair. So if I see a pair, because it's square root, square means 2, pair means 2. If I see a pair, it comes out of the radical. If I do not see a pair, it stays under the radical. So I have one pair of 11 and no pair of 2, so it stays under radical. Right here, it says, watch the video I sent you on Edmodo involving simplifying radicals. I sent you a video on December 12th, 2016. So find that video on your Edmodo account and just review over how to break these down again if this doesn't help. So that should help you. Okay, class, look at number 29. And it says challenge, but it's quite easy. In exercises 29 through 30, solve for x. On 29, I suggest using the Pythagorean theorem and Pythagorean triple to answer this question. If you look at the large triangle, I want to do this in phases. I want to go from the large triangle all the way down to the smallest triangle to get to my x. So I have to do this in phases. If I start the largest triangle, this is a Pythagorean triple. If you refer back to your key concept on page 429, you can see that with me. I have 36 and 39, and the missing number is 15. So my leg here is 15. Now, you want to look at this second largest triangle. I have 15 and 9 already given to me. This is also a Pythagorean triple. So if you look back on your page, I have 15 and 9, and the only number missing is 12. So my leg is 12 here. Now look at the third largest triangle, which is here. They have given me 10, and I have 12 here. So if you look at this, I have to do a little work here because I don't have everything I need just yet. On this problem, I also have 6. So they have given me 6 and 10. I need to find the measure of this part of my leg. I know that the total measure is 12. So I can look at the Pythagorean triple again, and they have 6, 10. The missing part is 8. So from here to here, that's 8. I know I need to find out what this leg is though. If this entire part is 12 and this part is 8, 12 minus 8 will give me 4. So this missing piece here, it will be 4. So now for my smallest triangle, which has x involved, I have 4 and 6, and I need to find x. This is not a Pythagorean triple, so I'm going to have to work this out using the Pythagorean theorem. I know that since this is a 90-degree angle, I know that this is a 90-degree angle here. And you can use that for multiple reasons. We know we talk about so many different things. We talk about the linear pairs. We talk about straight angles. We talk about perpendicular lines. So all those things that we've talked about tells me, confirms that this is a 90-degree angle. I know across from the 90-degree angle is my hypotenuse. So x is the hypotenuse in this problem. Looking at this smaller part, I have a leg of 4 and a leg of 6, and I need to find x. So apply the Pythagorean theorem. 4 squared plus 6 squared equals x squared. Multiply the parts together. 16 plus 36 adds to give me 52. I want to complete a factor tree again. So I know that 2 times 26 is 52. 26 is not a prime number, so break it down again. 2 times 13 is 26. So I have a prime number of 2, 2, and 13. And I want to put those underneath the radical. I see one pair of 2's. So that I write 2 down one time because it formed one pair. And I have a square root 13. I have a 13 left over, so it goes under the radical. Another way you can do this is you can type it in. So I want to type it in on the graphing calculator. So on the graphing calculator, the way I would type this in is a tad bit different from the Casio calculator I used earlier. I'm going to say second, and then I hit the x squared button. If you look above the x squared button, you see a blue square root symbol. Hit that button. You have a second. So whenever you say second, the second it leads you to everything that is blue, in blue. The green color will lead you everything that's it'll lead you to other things. That one's not necessarily color coded, but it'll lead you to other features. But the blue will lead you to the blue parts of the calculator. So again, I want to hit second x squared, and then I want to type in my number, which is the square root of 52. And you say I have square root of 52 here. And then I want to press enter. Press enter. And it gave me an answer of 7.21. Okay. Going back to the Casio, because the question says we want to solve for x, so I want to show it to you in radical form as well. We're going to say square root, type in 52, and it gives it to me in radical form, which is 2 square root 13. Again, you hit SD if you want to look at the decimal form. Last question. It says, in baseball, the diamond of the paths between each pair of consecutive bases is 90 feet, and the path form right angles. How far does the ball need to travel if it is thrown from home plate directly to second base? So it's a very loaded question, but very easy. So we know what a diamond image looks like. So here I have an image of a baseball pathway. And we have first base, second, third, and home. They said here that at the different places they're consecutive. We know consecutive is one behind the other. At each base, they said they form right angles. So if you look at this image, and I drew a line from home to second, I formed a right triangle. At the right triangle, we know that my 90-degree angle is here. I know that my distance from home to first is 90 feet. And from first to second is 90 feet. So I have an isosceles triangle here. I want to apply my Pythagorean theorem because I need to know what is the distance from second base to home. So applying the Pythagorean theorem, you have 90 squared plus 90 squared equals c squared. 8100 plus 8100 equals c squared. Add these up to get 16,200 equals c squared. Square root both sides of my equation. So c is approximately equal to 127 feet. So it's telling me that from home to second, or second to home, the distance is 127 feet. Very important that you always include your units when you're working with these problems. Okay? Make sure you read and study.